In the late 1800s, physicists were running electricity through vacuum-sealed glass tubes just to see what would happen. They weren't looking for the laws of the universe. They were mostly just tinkering with current. A typical laboratory back then was a chaotic mess of wires, heavy coils, and hand-blown glass. It was an era defined by trial and error. When they isolated a specific element, like hydrogen gas, inside one of these tubes and hit it with a spark, the gas would emit an eerie, distinct glow. According to the established physics of the day, light was a continuous wave. If you passed that light through a glass prism, it should spread out into a smooth, smeared rainbow of color, exactly like sunlight does. The math supporting that continuous wave theory was completely trusted, until they put a prism in front of the glowing hydrogen. Instead of a continuous rainbow, the prism projected 4 sharp, isolated lines of color, separated by total darkness. It looked like a barcode. Researchers meticulously measured each line in nanometers: red at 656.3, blue-green at 486.1, blue-violet at 434.0, and deep violet at 410.2. This was raw, empirical data, just a short table of numbers. Yet there was no known physical mechanism that could produce it. The immediate assumption was that whatever was inside the atom must be acting like a tiny mechanical oscillator, a vibrating spring. But a tuning fork or a spring rings with a single primary frequency and maybe a few predictable harmonics. It doesn't emit 4 rigid, wildly spaced colors and then stop. Physicists tried another model, imagining the atom as an electrical charge moving in a circular orbit, but the math was worse. A circling charge continuously bleeds energy. It would emit a smear of all colors, spiral inward, and collapse into the nucleus instantly. If the classical rules of motion and electricity were true, those 4 lines couldn't exist. The atom itself shouldn't even be stable enough to hold together. While the physicists were struggling with the structure of matter, a Swiss mathematician named Johann Jakob Balmer looked at those 4 wavelengths differently. To him, it was just a numeric puzzle. He didn't care about particles or springs. He just sat down with a piece of paper, manipulating fractions, looking for a hidden sequence. He found a bizarre formula. Watch what happens if you plug the integer 3 in for n. The math spits out 656.3, landing perfectly on the red hydrogen line. Plug in 4, 5, and 6, and it hits the next lines exactly. Balmer's formula predicted physical reality with total accuracy, even though the math had no grounding in the established laws of physics. The scientific community was left in a highly uncomfortable position. Their physical models were broken, and their only working tool was an abstract formula with a mysterious integer pulling all the weight. If you strip away the constants, the formula reveals its core structural logic, one fraction being subtracted from another. This subtraction implies that a specific wavelength of light represents the exact difference between 2 separate values. Those fractions suggested that whatever was happening inside the atom was happening in strict, discrete steps. You couldn't be between the numbers. You were either at level 3 or level 2. The simple act of analyzing a glowing gas had exposed a secret quantized architecture, leaving physicists with a precise mathematical result they couldn't yet explain.